Hello, everyone. Welcome. This is Jason Rose from RUPES. Welcome to our episode this month of the Core series, which is our continuous online RUPES education program. And we have a fantastic topic for you today. Not sure what time it is in your part of the world, but we have people watching from all over the world today. So thank you for being here. I am in our BigFoot Academy in Denver, Colorado in the United States. And with us also in Milan, Italy at our BigFoot Academy there is Fabrizio Gagliardi.
Good morning, buongiorno, hello everybody. Thank you, Jason.
Okay, so what we want to do is walk you through this topic, and today's topic is on polishing pads. So we'll jump right in, but before we get too deep into this topic, I want to just point out a couple of things for you. On your screen, there are a few boxes, and you can actually size those boxes and move those boxes around on your screen. But there is one box that is called Resources, and there are some downloads there available to you. There are charts that we're going to go over during this webinar. So those are things that you can download later at the end of the webinar. There's also a chat box, and this chat box is where you can type in comments and questions. And at the end of this presentation, Fabrizio and I will have a question and answer session, and you can ask questions, and we will try to answer as many as we could. On the last session, we got over 70 questions, so we could not answer them all, but we will try to answer as many as we can. So keep that in mind, and then also available to you is after this webinar concludes, you will get an email with a link, and you can also watch the webinar again on demand using that link. So with that, I will begin. Again, audio, we can't hear you, so no sense you asking questions verbally, but if you have any comments or questions, just type them in the chat box, and we will try to attend to those as best as we can. So this topic is on polishing pads. And with this topic, we are going to weave in a lot of education about the materials themselves that polishing pads are made out of. With that, we will also weave into the presentation a lot of information about our RUPES polishing pads, so our products. But this is not going to be one long infomercial on RUPES pads. It's going to be primarily educating on pad types and pad materials. So with that, we're going to go right into these three categories of materials that are primarily used for all polishing pads around the world. And the three materials we're talking about are foam, microfiber, and wool. So we will go through these three materials and speak a little bit about each one, the characteristics of each one, and how they're applied. So we will start with foam. And with that, some general comments about foam. First of all, this is a material that was started to be used in the early 70s, in the early 1970s. It was invented as a polishing medium in the mid-60s, but it became more popular in the 70s. And of course, now it is a very broad category with lots of options for you as technicians and detailers. So you have lots of different choices on foam pads, different shapes, different types of foam, different purposes, different diameters, different tools, etc. But this is a very complex synthetic material, meaning that foam pads are, man-made formulas, and they're very, very complex. In fact, these foam formulas that are used for polishing paint have 9 physical properties. These properties don't always apply to other uses of foam for example, seat cushions and filters and things like that. But for technical polishing foams, there are about 9 physical properties that make up the formula. Those 9 properties are on your screen now, and we'll go through these real quickly. The first one is porosity, and that is the little air bubbles, the cells in the foam, and that is porosity. Pores per inch is a unit of measure for foam, and that is literally counting cells in a certain area. So porosity can be more or less in these foam formulas. Next is density, and that's how many of these cells exist in a certain area, and how thick those cell walls are. Next is tear resistance, and this is the ability of the foam formula to withstand a stretch. So it's an industry test actually on foam, very, very standardized test, but it's a way of stretching foam and then understanding the tear point when it begins to tear. We also have elasticity, and that's obviously how stretchy, how much the foam stretches out. And then also stiffness, so that's how stiff the foam is. And then there's a property called load deflection. Load deflection is the force at which, when you compress foam, that the foam pushes back. That is called load deflection. And there's several different industry tests for that in foam. Then we have memory, and that is the ability of the foam to retain its compression when you compress it. Memory, I think you're familiar with memory foam mattresses, but there's some memory properties in some of these polishing pads as well. Then we have tensile strength, and that is the strength of the actual cell walls within the foam. And then there is a property called hydrophobic or oleophobic, and this is a property about the foam, how it handles fluids. So how it handles water and oils and other fluids. So these 9 properties, as I mentioned, very complex how these foams are made up, but these are properties that foam makers can adjust for different performance. So with that, we will go on to what happens on the surface. So when we use a polishing pad and we put it to paint, what is going on in between the foam and the paint? Well, the first thing is that the way the foam is structured, we have this pushing and pulling of the abrasives across the paint surface. And that is because the abrasives get into the cells and they hold there, and then they get pushed around on the surface. So fluids actually go through foam in a hydraulic motion. And basically what that means is when you compress foam, the fluids that are in your compound and polish, they can actually get pushed through from one cell to the next cell. So when you compress foam and there's fluid on here, it will get pushed through those cells. And then also when you release, there's a hydraulic effect and the fluids move through the cells. So foam has a surface area like all these polishing materials do, and the surface area is generally less on a foam pad than it would be on microfiber or on, foam would be slightly more than wool. So it would be, the surface area on foam would be slightly less than microfiber, but perhaps a little more than wool. And what we mean by surface area is the actual touch points of the pad material to the paint surface. So this is what we call surface area, the surface contact of the pad to the paint surface. So with that, we want to talk about this other property in foam, and that is called reticulation. The common words used are open and closed cell. So that means the cell walls are either completely intact and closed, or the reticulation process actually blows out one of those cell walls in every cell, and that opens up that cell. So that is called open cell foam. And in the RUPES product line, all of our foam pads that are in our product line, all of the foams we use purposely are open cell foams. And one of the main reasons is this characteristic about airflow. So with open cell foams, you have this ability to allow air to migrate in and out of those cells more freely. And the closed cell foams tend to restrict that flow a little bit. And that means that the temperature could be higher in those pads. And with our tools, with the movements we have, we just chose open cell foams. So in our product line, we have 4 different levels of foam. And this is in our BigFoot Random Orbital product line. And these 4 levels represent different levels of aggressiveness and different levels of finishing for the foam. And there is blue, green, yellow, and white colored. And those colors correspond to the different levels of foam that we have. One of the other physical properties that we have put into our foam pad products is this concept that we call lateral stability. So the lateral stability is the ability of that foam to maintain its structure with a side-to-side motion. And some of these traditional foams, perhaps the foams that were made for Rotary, the other foams that are on the market, they may not have this lateral stability built into the product. And if that is the case, that foam pad on our tools could possibly generate more heat because a lot of the energy of the tool gets lost in the movement going side to side in an orbital movement. So we have deliberately put in this lateral stability, this structure in the foams, so that more of the tool's energy can be more efficiently transferred to the paint. And that, of course, is desirable for efficiency. The next thing we want to say about foam is that foams can absorb in compound and polish, and sometimes too much. And we, as users, we want to be mindful of this, what we call saturation. So we want to just make sure that the foam pad does not get saturated too deep into the foam with compound, because especially on the random orbital tools, as they move with their large orbit, that heavily saturated compound in the pad could actually throw off the balancing movement of that tool. So it can generate more internal heat inside the foam, and it could also create more pad drag on the surface because of that heavily loaded compound on the pad. So the message here is pay attention to saturation. Make sure that you're not hosing on too much compound on the pads as you use them, because this saturation is not your friend. It's not helping you with performance. And good for you that RUPES, in our tool design, in our movements, in our foam, and in our compounds, we've done everything we could to try and mitigate this saturation from happening, so it's actually part of our system. The other thing we could say about our foams is that we have 3 complete different foam pad systems. There is the foam pads that are in our random orbital system, which many of you are familiar with. Then we have the foam pads that are in the Melee gear-driven orbital system. And you'll notice that those are actually a completely different shape, and they have a completely different design. As well, the Rotary foam pads are yet a 3rd new design. These pads, if you put them all 3 side by side, they visually appear similar in the foam type, but the reality is that they have a different design, a different shape, and potentially different actual foam formulas based on these different movements and these different tools. So it's not just one foam fits all. We have different foam formulas for different tools and even different purposes. So with that, we want to talk about priming foam pads, and the recommendation we do here is we would put 1 to 6 pea-sized dots of compound on the pad. And we say 1 to 6 because it really depends on the pad diameter. 1 to 2 dots for the small foams, and then maybe up to 4 or 5 pea-sized dots of compound for the 7-inch foam pad for the 21 millimeter tools. So you put that amount of compound down, you put the pad to paint, and then you pull the trigger and you run the tool at a low speed setting, like speed setting 2 or lower, but the point is a low speed setting, and you run it stationary in one place for about 30 seconds. And the purpose of this 30 seconds of stationary running the tool, it's to warm up the foam and warm up the compound. And with that, it allows that compound to spread more easily across the foam surface. And it actually activates your suspension system in the foam. So once it warms up, it won't be as stiff and it can actually suspend. So this priming is important that you do this first before you begin your applications on the car because you'll get better performance that way. Once you're primed, you'll notice that the compound is spreading more freely throughout the pad surface, and you reload compound with a small amount of compound, like 1 to 3 dots of compound. That's your what we call reload, and then you're ready to go. Next, priming the foam pads for the Miele gear-driven polishing system. It's a little bit different on these pads. We are recommending you put a bead X product, X pattern on the foam pad instead of pea-sized dots. Now, why not the dots? Well, if you put pea-sized dots on this tool with this particular predictable movement, the chances of it spreading and migrating throughout the whole pad, it will take a lot longer. So it's important that you get compound on the whole radius of the pad, because any dry parts of the pad with this system is going to cause pad drag. So we put an X of compound, put the pad to paint, run the tool for 30 seconds in a stationary position, and that will prime the pads for the Miele gear-driven system. Next, we will go into priming for rotary, and the rotary movement is completely different movement than the gear-driven and the random orbital. And if we did dots or X's with this rotational movement, what would happen is any product that we place on this pad, as soon as we pull the trigger, that product will get thrown across the room. So any product, especially on the outside of the pad, as we turn on that tool, it's just going to sling. So we need to be creative about how to prime this pad without making a mess and slinging it all over the place. And the way we do that is we call picking up a bead. So we put a line of compound on the paint surface, and that line will be about as long as the diameter of the pad that you're using. If it's a big pad or a small pad, whatever that diameter is, that's the length of the line of compound. And then, very particular motion here, but you will go from your right to left. And the reason is because the rotary will only go in one direction, it won't go the other way. So it has to be from your right to left Otherwise, if you go from your left to right to pick up this bead, it will throw product away, but going from right to left, it will suck it down into the center of the pad. So this is how we do this. We pull it across that bead, and then we lay the pad down flat and run the tool for about 15 seconds. The reload for rotary is the same. It's a very small amount of product, because once you're primed, you should be good to go. So 1, maybe 2 pea-sized dots to reload that pad after you're primed. Cleaning foam pads, the recommendation is to use either compressed air or the RUPES BigFoot Claw pad cleaning brush, or a nylon bristle brush, some kind of a pad cleaning brush. Those are 2 very popular ways. The compressed air will be more efficient and more effective. So if you have the ability to do compressed air, that is really the best way to clean foam pads as you're working on the car. So with that, we have discussed foam as a material category. That's the first of 3. I'm going to kick this over to Milan, Italy, and Fabrizio will talk about the next material, which is microfiber.
Yes, thank you, Jason. Thank you. So let's go and see some of the main features of microfiber. Let's see what we're saying. It's the most recent technology. It was born and developed in about the 10th of the century. We have several options. Okay, we have a quite complex composition of this material, and we can change, and better, the producers of microfiber can change the features of this material depending on the kind of behavior that they expect and that they want from this material. So we have 5 possible variables that we can change, and these variables are the thickness of the microfiber. It's a microfiber, so for sure it's a very small thickness, but we can change it a little bit. The pile length, of course. We have a blue and a yellow, we will see it in a minute, with different pile length. We have a different ratio, polyester, polyamide. So these are the 2 main components. If you see in the picture, one of the 2 materials is polyester, the other one is polyamide. And changing this ratio, we can change the hydrophobicity or hydrophilicity. So we can change the behavior and the ability to take out water or grease or dirty. Number of vertical slits and strand density, so how many fibers we have in a square inch. Changing this, we can change the behavior of the microfiber, but what happened is that what the microfiber does on the surface is slicing. So it just cuts out pieces of material from the surface. The abrasive will remain attached to the fiber. Fluids will hold on to fibers. So what happens is that what we normally say is that it grabs and holds material from the surface. The reason why this kind of material is more aggressive than foam is that the surface area working is higher. So we have a lot of surface in contact with the paint, and we can take out material quite fast, quite rapidly. So this is the mechanism, how it works. While a normal natural fiber can be wool, can be linen, can be any fiber, cotton, for example, will just move dirty from one place to another one. Microfiber will capture, will take it, will grab and hold this material. So it will just not be there on the surface anymore after that. It is a split fiber, meaning, again, 70–80% we can change this ratio. 70–80% is polyester, 20–30% is polyamide. So this gives us the possibility to change the features and the behavior of this material. It is a blended material. It is the blending of these 2 components. What is interesting and what the reason why it appeared on the market only a few years ago is that there is a high engineering behind the creation of microfiber. And look at this picture. On the left, you see the thickness, an example, the ratio. Look at the ratio. The thickness of microfiber compared to the thickness of any regular natural fiber is the same ratio that we have between a pencil and a big basketball, a regular basketball. So we have a material that is totally engineered and very advanced. Okay, this is the structure of the polyester. So this is of the microfiber. So we have the smaller filament, which is all connected to other filaments like them, giving a strand. These strands are bonded together to give a yarn, and this is knitted or woven to give the fabric. So in the end, what we have is all a very complex structure, able to do a very peculiar job on the surface we are working on. So how do microfiber pad work? We have a dramatic increase of the surface, so a lot of material working on the surface, a lot of action, a lot of work, a lot of things happening between the microfiber pad and the paint or any other surface we are working on. The filament is going to hold the abrasive, and this abrasive will work on the surface. Of course, this gives a little bit more of heating, will increase the temperature of the job, and we will need to reload quite fast the material on the pad. So these two things make, all these things make microfiber a quite aggressive material, but that needs some delicate operations that must be done, like cleaning the pad quite often, and being careful on the temperature side. We have two levels. We have, let me take them, we have a coarse and a fine pad. Same color on the front, but different colors on the back, so you can distinguish them by watching if it's blue or yellow on the side of the pad. The coarser is more aggressive, but many times it needs a second step, especially if used with blue compounds. Instead, the finer, especially if used with yellow compound, will cut a little bit less, but will have a dramatically better finish, gloss, okay? Consistent color code, always for RUPES, blue, more aggressive, yellow, better finish. The polyurethane, this is manufactured here in Vermezzo. We have in-house production of these microfiber pads. There's no glue to keep together Velcro and microfiber. It's just polyurethane that binds chemically the three layers together. We also have these slots in the middle to cool down the temperature when you're working. This will allow us to have, it's also a patented solution that will allow us to work for longer time with these pads. Okay. How to prime the pad. This is different compared to foam pads. Foam pads, we have seen, they have open cells, so the compound is able to move through the pad. This instead holds and grabs. So we must be sure that all the area of the pad is covered with compound to have a better user feeling and a better cutting and more homogeneous and consistent cutting from the pad. So what we do is, again, set it at a low speed, but make sure that all the area is covered. So we need to go all through a thorough dispersion of compound all through the surface of the pad, and then probably using a claw pad tool, we can make sure that all the area is covered. Then working for 15 seconds, 10 to 20, okay, seconds, just stationary or with small movements, and then add reload if needed, and then you are ready to go. So the important thing in this case, the same with all fiber pads, so we'll say the same thing with wool, is to make sure that all the area is covered with compound. How to clean them? You can use claw pad brush. You can blow with compressed air. There's this tornado system that with fiber pads is working very well. Probably you know the gun that rotates, and it's very good with fiber pads. So we strongly recommend to use air and to do it often, because after a few minutes that you're working, microfiber will be completely loaded up with paint, with residues and dust, so it must be cleaned often. The other solution that has been a major innovation in RUPES, in my opinion, and it's personally my favorite solution, is wool. Wool is not a new solution. It's the opposite of microfiber. It's the oldest one. It has been there for years. It started in the 50s, but it has been there continuously since then. And there is different solutions. And there's a lot of technology still going on in this kind of material. Mostly are natural fibers, so just coming from sheep and animals. Some are synthetic, so man-made, just like microfiber, but what we think is that the best one is the natural, and that's what we use for our wool pad. Again, some variables that we can introduce about fiber is the material, synthetic or natural, and kind of we will see some examples of different materials that can be used in wool pads. The blend of material, we can blend different length, pile length. We can have different thickness of the material, of the strand. We can have twisted or untwisted. We can have different densities, so different number of fibers per square inch. And the kind of substrate. We use this one with a foam substrate. There are different others. Let's see some more examples about that. Samantha, okay, thank you. So what's the kind of action that wool does, the wool fiber does on the material? It's scraping. So we are kind of rubbing out material from the surface, because these strands, these fibers, since especially if they are natural, they have a strong abrasive action, so they will really rub onto the surface. Fluids are semi-absorbent, so they might be absorbed. That's the reason why we suggest to, again, thoroughly prime the wool pad. And normally we have less surface area than microfiber and foam, but anyway, quite a lot, so we need to be careful about overheating the paint. These are some examples. We are saying we might have coarse and fine fibers. We can have finer. We can have silk, which is not really common, but some pads are on the market about silk or linen. And polyester, you see the difference between wool or natural wool and artificial polyester. Polyester has a very flat surface, so it's smoother, less aggressive. That's why we decided on wool pads, which is normally used to the aggression, to cut, to use normal natural wool, which is more aggressive and does a better job. Then we also have different categories, different geometries of the pads. We can have the dish style, which is quite common in the US, but also now all over the world. It's probably the most aggressive kind. Then we have the tufted, which can be used in both sides of the pad. We have the Euro one, which is a simple substrate with some wool fibers attached. And we have the Asian one, that is the kind of technology that we adopted for these pads, because they are the best performing with dual action machines. So these have been specifically designed for dual action machines. We have two levels again, coarse blue and yellow fine. Both of them anyway dedicated to gear-driven or random orbital movements. What changes between the two materials? Okay, we have seen that it's engineered for our three systems that have dual action, so might be gear-driven, triple action, or random orbital. So we do not suggest to use them with rotary, albeit a lot of people used it and say it's good, but we suggest to use these two pads for dual action machines. The difference between the two pads is the blue one has a dual fiber density. We have two different fibers, two different lengths, 5 and 8 millimeters. So it's a dual fiber density. We have a quite stiff blue foam backing the action of the wool. We have a fastest defect removal, and again we have all the measures. While for microfiber we only have 75, 125, and 150 millimeters. For this we can have from 30 to 170 millimeters pads. So also for the nano, also for the very small one. So if you need to take out deep scratches or deep sanding grits, you can do it with a nano. Then we have the yellow one, which has a longer fiber. It is 15 millimeters fiber, and it is very good finishing. So while the blue one usually requests a second step, this is, especially if used with yellow compound, it can be for a one-step job. Good cutting, but also very good finish. How to prime it? Quite similar to the microfiber. Since this tends to absorb some compound, then we again suggest to apply a thorough quantity of compound all through the surface, and do not leave any dry area, because it will give you some bad feeling when you're working it. So if you want to get the best user feeling, user comfort, then a good priming process is requested. How to clean it? Just like microfiber. Blow with compressed air or use gelcoat tool. For me, the best one is, again, compressed air, but if you don't have a compressor, or if you're working like a mobile, which you don't have the access to some compressed air, you can easily use our gelcoat tool. It will give you a very good result. I think this was my last slide for this slot. I will give again the voice to Jason.
Okay, thank you, Fabrizio. Well done. And what we will do now is transition to, from talking about the actual materials themselves, we will transition to comparing the relative performance of using these polishing pad materials for different purposes. So we will go through some charts and we will compare performance. As we do this, we will be looking at this color code, this color code scheme to compare relative performance as kind of a quick and easy way. Now, these charts I'm about to show you, they can be downloaded in the resource box on your console. So when we think of performance, the general relative performance when we're polishing paint using these different materials, we want to look at things like defect removal speed, how fast does the material remove defects, as well as how well that material finishes on the paint. In other words, removing defects but leaving the paint defect-free. And also the user experience, because these different materials can have a different feel to the surface, and the smoothness and how it applies to the paint can be very different from material to material. Also the learning curve. So this is about how long it takes to master using this material as a polishing medium, as well as the efficiency. And with efficiency, we're talking about time and steps. And with these materials, depending on the procedure we're doing, it could mean more or less time or steps. So let's look at this. We will look at cutting ability between these three polishing materials. We will give the gold stars to the microfiber material. And this is within the RUPES pad systems. The microfiber material, if you look at just raw cutting power and removing defects, the microfiber will be the clear winner. We give the gold stars to microfiber. However, if you look at the number of stars there, the gap in performance between microfiber and wool and microfiber and foam and wool is not that big. So they all remove defects. They all do cutting power. So the gap is not very large, but a slight edge to microfiber. Secondly, finishing ability. If we look at these materials, we clearly give the gold stars to the foam. Consistency over time, different paints, different climates, different severity of defects, all things considered, the foam material will leave you the best consistent finish relative to the other materials. And that will be followed by wool and then microfiber. So with a user experience, when we're talking about smoothness, pad drag, things like this, the foam is very, very smooth on most paint surfaces, so that will get the gold stars. And then remarkable is our new DA wool pads, our dual action orbital wool pads. Once these are primed sufficiently, they are actually very, very smooth on the paint. So that is another option for user experience. Then on the learning curve, as far as how long it might take the average user to really master these different materials, we will give it to the gold stars to the foam again. All things considered, if you're trying to learn how to really master and get the best performance of these materials, you can get there faster with foam. And then our wool pads are actually pretty easy to use. The microfiber, however, which we'll talk about in another slide, there is some dependency on proper priming, proper cleaning, and proper technique. And that is part of the learning curve with microfiber. Next would be the efficiency. And this is literally how much time and steps that's involved with these types of materials. Again, we'll give the gold stars to the foam because all things considered, with most levels of defects and most types of paint, the foam material can get the job done very efficiently and quickly, followed by wool. Our new wool pads are fantastic for that. The next chart I'll show you, and we're going to get into two charts about refinish paint. And what we're talking about here is freshly sprayed paint in the collision repair or the custom painting industry. Now, in that world, the paint condition can actually exist in three different ways. The first way we talk about is very, very fresh. We're talking within hours of being sprayed. And this could be very wet paint. It could be over applied. So the painter accidentally hosed on too much clear, which is not a good paint condition. And then also under cured clear, which is paint that's not mixed properly or not force cured properly. So in this scenario, this paint condition, these materials perform differently, and we will give the gold stars to the foam because in this paint condition, very, very wet, very fresh, perhaps under cured, the foam pads will perform better. Microfiber will simply be too aggressive, so we don't even recommend it for this paint condition. And then wool can sometimes perform well and sometimes work against you. Now, when the paint changes and it ages, and we're measuring this change in hours now, so freshly sprayed, 4 to 48 hours later, the solvents are outgassing, the paint is becoming harder, and the cross-linking, the curing process is advanced, and the paint is actually different. It has completely changed. So with this change in the paint condition, these materials will polish differently on that surface. So we will give the gold stars to our new wool pads in that scenario. So in this paint scenario of fresh paint but fully cross-linked cured, first day, second day, the wool pads, absolutely fantastic for removing sanding marks and removing defects. The foam pad will do pretty good. Microfiber will still suffer a little bit in this condition. Now, going on beyond days and weeks and months, this fresh paint becomes fully dry, fully cured, all the solvents have outgassed, and the paint hardness has developed to whatever it's going to be, and the paint has settled into whatever condition the paint is going to be. And in this scenario, we go back to foam, and the foam pads perform very, very well as this paint has aged and it's fully matured, and the foam pads perform really good in that scenario. And as you can see by the number of stars, the wool pads are not too far behind. They are a great performing product on fresh paint. With that, we'll move into another kind of paint that most of you are on almost every day, and that would be on factory applied or OEM applied paint on factory built cars. So we again further divide this into other subcategories. So we categorize factory applied paint as standard, and then there's soft, and then there's hard OEM paint. And then we also add in gel coat, which is your boats and RVs, completely different material, but can also be factory applied. So we will go through these scenarios together. With OEM standard, so this is most of the cars, most of the paint types that are applied at the factory. The best material would be the wool pad. And again, we're talking about the average or the standard hardness on factory applied paint. The new RUPES wool pads are phenomenal, and they can be used on either the gear-driven melee tool or the random orbital tool on that factory applied paint. Next, we have a paint condition, also factory applied. Generally speaking, this condition is in the Asian markets, but it is experienced elsewhere in the world. But this we call soft or sticky paint. Sticky paint is a condition where the paint could actually be, it's not wet, but it's so soft and the surface tension is so different than what it should be that any compounds actually absorb very, very quickly, and removing defects is a big, big challenge for this condition. We don't recommend microfiber, and primarily because of surface area. So on soft, sticky OEM applied paint, surface area is not your friend. You actually want to polish in such a way that you have less contact with the paint, not more. So microfiber having more surface area would not be recommended for this paint condition. The wool pads actually have, although it looks like a lot of fibers, these wool pads, if you actually look at the contact points to the paint surface, it has a very low surface area contact to the paint. So this makes it a very good choice for the soft and sticky paint scenario. Next, we have OEM hard paint. And this is paint where the defects are coming out very, very slow, and that's how we know the paint is hard. So in this scenario, we want to boost the defect removal power, so we choose a material like the RUPES BigFoot microfiber pads. This will give us more surface area and faster defect removal, more defect removal power. However, the new wool pads are very, very close. Sometimes they could be interchangeable in how good they perform on OEM hard paint. And to Fabrizio's point, this is his favorite, and it's quickly becoming a favorite of many of our customers because of how well it performs on a variety of paints. The gel coat scenario, and this is a very, very porous, very hard, very thick surface, mostly on boats and RVs. We don't recommend microfiber because, as Fabrizio mentioned in his segment, microfiber will grab and hold things, including the oxidized residue from an oxidized gel coat surface. It will very quickly load onto the microfiber pad and make that pad not perform as well. So in that scenario, we recommend the RUPES TA wool pads, which is a great choice for oxidized gel coat. It will cut through that material and remove it from the surface. A good second step on gel coat would be switching movements, go to a random orbital movement and finish with foam. So that's a good tip on procedure. Next, we have application comparisons, and this is what we're talking about in terms of user experience. How is it to use these different materials? And we have a thing called priming dependency. So these materials will perform good or bad depending on the quality of the priming that the user does. So with foam, it has the least dependency on priming because you can be sloppy about the priming perhaps because foam, with its hydraulic characteristic, it will actually self-prime over a few applications. So priming is not as critical. However, with wool and microfiber, there is a strong dependency on priming because the product will simply not work as well if it's not primed properly. Next, we will go into the dependency for cleaning. The foam actually can go a further distance and be used for a longer period of time without having to clean the pad surface. But again, the fiber pads, microfiber and wool fibers, they need to be cleaned, especially microfiber. If you do not clean those pads as you go, you will lose performance. So the frequency of cleaning is actually more with fiber pads. And we talk about durability of these materials over time as you're polishing, and we will give the gold stars to the microfiber material as being the most durable under those conditions where they're being heavily used. And then that would be followed by the wool and then foam. Now this characteristic we call pad drag has to do with surface area and the footprint of that surface area on the paint. So foam, with its cell structure and all the little air bubbles that's on there, it would have, in a lot of scenarios, generally speaking, the least amount of pad drag, whereas microfiber with the most surface area would obviously have the most amount of pad drag. And that means you could be fighting the pad, you could be losing rotation a little bit with random orbitals, but that is a function of that pad drag. And again, these charts, if I'm going too fast, these charts you can download in that resource box. So here's another way of looking at these materials, and this is looking at them from the perspective of what tool you're using with the pad. So we're not going to compare using our color scheme, but we will have some general comments to make. With random orbital, with our BigFoot random orbital system, with these three different materials, with foam we can expect, generally speaking, the best all-around performance with the random orbital. And with microfiber, you can actually get better performance with random orbitals on hard paint. So that is where it really performs well, is when you're on those harder paint systems. And then with wool, has absolutely outstanding cut and finish, and you get the best of both worlds with these wool pads on a random orbital. It's absolutely fantastic performance. Then with gear driven, if you look at these materials in the polishing products, you can see a big red box. We do not recommend the microfiber pads on the melee gear driven movement. And there's a lot of reasons for that, but the main one is that it ramps up temperature way too fast with this movement, so we don't recommend microfiber. But on the gear-driven tool, foam is outstanding on fresh paint scenarios. It does really, really well. And then the gear-driven tool with wool pads, you get the benefit of that strong cut and that strong finish with that gear-driven movement. Now the Rotary, you'll notice we also do not recommend microfiber pads with the Rotary system. Again, the temperature ramps up way too fast, and the fiber is actually way too small, and it creates a pattern on the paint that we don't like, so we don't recommend it on Rotary. However, with the Rotary system, the foam pads do a great second step finishing on any severe defect removal procedure. And then wool pads will do your best cutting of a sanding mark and severe defects. Our new DA wool pads are not recommended for Rotary, but we will very soon have a wool pad product specifically for the Rotary system. So with that, I'm going to look at, actually I'm going to switch this back over to Milan, Italy, to Fabrizio. What I've done is looked at some general performance comparisons using these different polishing materials. What Fabrizio is going to do for you now is look at some very specific challenges, some problems, and how can these materials help you get out of a problem, and which material would perform best in certain situations. So we'll turn it over to Fabrizio.
Thank you, Jason. These next few slides I think are very interesting, so I kindly recommend to just follow what I'm going to say, and is also answering to some of the questions that in the meantime arrived. When should I use one? When should I use the other? Jason did it, let's say, more on the theoretical side. I will do it with some practical examples. So let's start with one real condition that you can find when you just do your job, whether it is detailing, whether you work on cars or other materials. Now, there are some good examples. So let's suppose you're working on a car with a 12 hours old, so quite fresh paint, properly applied. You want to remove sanding marks, 2,000 grit, so quite deep, big scratches made by the paper. Which pad material you would likely give you the best result, okay? Now there are a couple of elements that you have to consider now. It's a fresh paint, but it's properly applied and properly cured, so it's not soft, it's not sticky, it's quite hard but fresh. And you have 2,000 grit, not 3,000, not 5 or 6,000. So you have to do a quite good action, aggressive action on the surface. So not foam, because foam would be too soft, would be too kind on the paint, too gentle. Not microfiber, because it's anyway a fresh paint, so it might be too aggressive. Wool is the best possible solution in this case. Let's see another example. A customer wants you to detail his black car, so we have a black, which is always the most difficult to deal with minor defects on the surface, and the paint is known to be extremely haze prone, so it is delicate, and with too much aggressive action it will become too bad. Using a gear-driven or a random orbital polisher, which pad type would you choose? Of course, we cannot stand on the aggressive side. It's better to choose a combination which is a little bit more delicate, more gentle on the surface, and foam is the right material in this case. You're asked to detail a heavily oxidized boat. Boat normally means gel coat many times. And you have a gear-driven orbital polisher. That's what you can use. That's what you have with you. Which pad would be the most effective choice? Now, it's heavily oxidized, means it's in a bad situation, but we cannot use microfiber. Jason told that microfiber is not suggested for oxidized gel coat, because after a few seconds it will not work again. It will not work anymore because it will be completely stuffed with oxidation. So foam would take too long. What we suggest in this case is wool. The car you're working on has very hard OEM scratch, so it's probably a German car with hard OEM scratch-resistant paint, ceramic coating, ceramic paint, something like that, with severe defects. You only have your random orbital polisher with you, so you cannot do the first pass with Rotary or any other. You must use a random orbital. Which pad type would you choose? We are on a very hard, we are with severe defects. That's the best possible condition for using microfiber pad. Foam might work, but it might take too long. Wool will work better than foam, but it might take too long as well. Microfiber will be the fastest and easiest solution to use in these conditions. You're polishing a car with thin paint, and you want to minimize material removal. You want to be gentle. You don't want to burn through the paint. You don't want then to go to the body shop, to the painter, and repaint the car. Which pad type would you use? Would you choose for the job? Of course, foam. Foam is the fastest solution for doing this job. No, not the fastest. The most delicate and the safest solution, sorry. You're running a high-volume detail shop. You have to do many cars every day, 2-3 hours, and the car must go, which is specialized in fleet work, so not too long jobs. You need to define a system for your employees using a Rotary. You have to be fast. Rotary polishers that will give a consistent result for all of them. You have many people working. You need to have always the same result. Which pad type do you use? So which one is the less dependent on technique? This is foam. Foam will depend less on technique and will give the same result or the most similar result for all the people working. Your shop lends a fleet account for dealership. You need a fast and easy to use solution with your gear-driven polisher to reduce the most defects in as little time as possible. What pad do you choose? Okay. In this case, we must use a gear-driven polisher. Again, we have to do a quite fast job, but we are using gear-driven, so it's less technique-dependent than Rotary. We might go to the wool side of the job. Okay. These were some examples on when to use the different materials. I will now leave the voice to hand the line over to Jason so that I can go and see some of the questions and probably push them on video if they're not being answered in written form. Jason.
Okay, thank you, Fabrizio. That's very interesting to go through those individual scenarios and what the solution, which type of pad material is a better solution. So what we want to show you now is this chart, which again is available in the resource box. You can download this now or later. But this chart, although it looks pretty crazy on the slide, but I'll explain. On the left axis is the severity of the defect. So on the bottom left is mild or small defects, and on the top of the axis is severe or heavy defects. Across the bottom of this chart is your paint hardness scale, and on the left is soft paint, on the right is very hard paint, and that is the bottom axis. So paint hardness across the bottom, severity of defects on the left. And in the middle, you will see pad recommendations for the cross-reference. So for example, very, very hard paint, lots and lots of defects, that would be in the upper right-hand corner of this chart, and that would be our fiber pads. So hard paint, lots of defects, we're going to recommend fiber, either microfiber or wool in that scenario. The opposite extreme in the lower left-hand corner of this chart is our foam pads, and that would be for mild defects or paint that's on the softer side. So this kind of gives you a visual on pad recommendations based on defects and paint hardness. So what we've done at this webinar is we've covered these 3 major types of pad materials, and we've gone through a comparison in performance. We've also evaluated very specific situations for each of these materials. And we hope this topic was educational, and we hope you learned something about the pad use and the pad performance, but we also intended to educate on our RUPES pad products. If you want more information, you can go to these sites for social media or for websites. RUPES has our main corporate website in Italy, and that is the one on the left side of your slide. And then on the right is the website for RUPES USA, North America. And then there are the different social media sites. These are reference points for you to go to depending on where you are. There's Instagram, Facebook, and email, and the website. So those are points of contact for us, and you can get some more information about our products that way. So with that, we want to definitely say thank you very much for taking the time, and we will open this up to questions that we probably are not going to be able to read every single one that we get.
We don't have so many questions, Jason. We don't have that many. We have probably just a couple of them that we will show on the screen. So it will be quite a quick going through those. Can you make a comparison about lifespan and the economic aspect? So this person is asking about a comparison between different materials and how much they last, and which one is also the cheaper, not because it costs less, but because it lasts longer.
Yeah. So I would say then there was a slide on this point about the pad durability. So I would say of the different materials, if you look at microfiber, wool, and foam, relatively speaking, the most durable material is going to be your microfiber, followed by your wool, and then your foams. That's the ranking on the actual durability of the material itself. But there are some ways to extend the lifespan of these pads, regardless of the material. And there are some very technique adjustments that you can do to help a pad last longer. Also, your cleaning method and your cleaning frequency, those will help you to have pads last longer. And you should be getting at least 5 cars out of these pads. And microfiber and wool, 10 plus cars out of those pads. So if you're not in that range on durability, then you probably can make some adjustments on technique that will help that pad last longer. The adjustment I would recommend is less tilt of the pad and more flat pad, and also pay attention to rotation, especially with the random orbital. Make sure that movement is rotating. It could be slow, but that rotation helps cool and make less stress on components. I think that answered that question. Did we answer that?
Just one more thing from my side. It's an interesting question. This is the second probably webinar that we do, but I think that a good idea about this would be in the next future, probably not the next future, but in the future doing something just about this. So a study of the economical aspect of our systems, how many cars I can do with 1 liter of compound or with 1 foam pad. So you just follow our websites and Facebook profiles and so on, and then you will probably find something about this in the future. We go now on a different question that is instead about UHS system. just a few seconds it will arrive. Okay, what about random orbital and UHS pad on hard paint compared to microfiber? That's also an interesting question, because UHS, for the people who don't know, the UHS is the gray pad with the UHS compound, which is dedicated to ceramic paints, very hard paint, just like microfiber. So Jason, when should we use one over the other?
Yeah, so I think this is primarily, the decision is driven by the severity of the defects. In mild defects, moderate defects, or severe defects, all three scenarios we know we're on hard ceramic paint. So the defects are going to come out slower relative to other paint systems. But when you look at the different materials, for example, the UHS gray foam, and you compare that to microfiber performance on that same hard paint, the defects will be removed more efficiently with the microfiber. Now, the UHS will definitely do it. It will just take a little bit longer. So the foam handles that hard ceramic paint very well, but it just takes, for severe defects, it will take a little bit longer. So on mild and moderate defects, the UHS gray foam pad would be a good choice. On severe defects, the microfiber will get those out much more efficiently.
Absolutely agree with you. Of course, there's a difference also in the finishing side and the gloss that you get. Microfiber will likely need a second step with probably yellow foam and yellow compound, while UHS is often used as a single step. So you can only take out moderate to mild defects, but it will finish with a very good gloss and with a very good finish, with a very good appearance. I think these were the two questions that we could not answer by written form, and this is the end of our webinar, of our today webinar. So again, thank you also from my side for following this webinar today, and I leave just the last word to Jason.
Yes, thank you, Fabrizio. Appreciate your input into the webinar, and thank you all for attending. And we invite you to come back on our future topics of our core series webinars. And with that, we will say thank you and goodbye, and we will see you next time at the next webinar. Also remember to do the survey, so please give us comments on how well this webinar was for you. Was it beneficial? Did you learn? Give us the feedback, please, on the survey. You will also get an email with a link that you can watch this entire webinar again on demand. So an extra bonus view for you. Thank you so much. Take care. See you next time.